comes up. Okay. Well, we'll have a brief meeting, and just if anyone else joins, they can also have this discussion. So, like you said, you've already reviewed the slides. I also posted some examples. There's a folder called examples. So let me see if I can show that as well. Let's see. I'll just share my whole screen is what I'll do here. So here, there's this folder called examples here. So there will actually be an assignment related to this that will be coming soon. I want you to take a look at. So we can take a look at these, and I can also talk about that as well. But there's something in the examples that there's something called you need to calculate P star. That will be in the next set of slides. That will be in the structural testing set of slides. So, but for now, like we talked about graphs. So part of why I have this set of slides on graphs to understand, how directed graphs with nodes and edges is that we can represent it's a section of code like a method or a function or even just a code segment as a set of nodes and edges in a graph. So let me get back down. So where is it? Okay, so like this, right? So if you have a sequence of lines of code, we can just say, okay, well, M1 leads to M2 leads to M3, for example here. If you have an if statement, you can say, well, the condition, we could see that as a node, and an edge leads to M1, which is what's inside of the if condition, and they both end up going to M2 either way. And then if else, we can do it like this with two sides. It's similar to if you've ever done flowchart things. It's similar to that, though in the flowchart we would take this if and we would make it a special kind of symbol, a decision node. But in this, where we're representing, it's everything is just it's a node. All right. So you have a loop. Loops we can have edges like this with nodes in our loop where we go, and then we come out. And the post-test loop, the do-while loop, also the same thing. So if we look at an example like this, where we could represent this set of code, these lines of code, as a set of nodes and edges, where we take this line and we make it a node. We take this if statement and we make it a node. We put what's inside of the if statement and make it here. Else over here, they both end up leading to S4. Then we have this loop with S5 inside of it, and then finally this S6. Now, if we look at more of a real code example instead of just these general, S. Can't remember what we call S, but condition 1, segment 2, condition 1, so forth. If we look at actually like a real type of line of code, we can say like 5. Now, the reason why 5 results in 3 separate nodes is because all 3 of these conditions have to be true in order for 6 to be reached. All right. So the way that Java works, so this is an example of Java code, that if this first condition is false, it doesn't even check the other 2 conditions. Right? I can't remember the special word for
operator.
that. Right, but the double
operator.
Right, that's right. The double ampersand though says that don't check the other conditions if this one's false. Same thing with the or. Don't check the other conditions if the first one is true. But if you had just a single ampersand, it would check all the conditions anyway. So the reason why this is important is because if this first condition is false, we don't even go to check the others. We just go straight to 9 over here. right? We just go straight out of the if and into the else. Okay, so rather than seeing all of this together as one big condition, it's actually, we kind of divide it up, and there's a reason for that we'll get into, because what we're getting into now is how to do a good job of designing tests and designing test cases. And the reason why we want to separate it out into all three of these as nodes is because we want to make sure we have a test case that sees this edge. So we want to make sure we have a test case where the first condition is false. But we also want to make sure that we have a test case that sees this edge. And the only way we see this edge is if this condition is true and this condition is false. And then we also want to have a test case that sees this edge, which means we want to have this condition is true, this condition is true, and this condition is false. And then finally, we want to have this one as well, which would be all three conditions are true. We don't just want to have one test case that sees the else and one test case that sees inside of the if. We want, because there are three different possible ways that we could end up in the else, right? You understand what I'm saying there?
Yes, it's very clear to me.
Okay, good, because sometimes those of us programmers, we think, well, we'll write a test case for the if, we'll write a test case for the else, and we're done. But when we have a combined if here, a combined conditional if, we actually need to test the multiple different ways that this if could be false, the multiple different ways that this if could be true. Okay. So anyway, so then when we break these out, so then 11 becomes a node. Notice that 12 also is a double condition. So there's two different ways that it could end up in the else, but only one way that it ends up in the true. Right, so two different ways that it ends up in the else, one way that it ends up true. What else? So then here, same thing with line 15, multiple possible ways that this could go. Okay. So notice that we always all end up here at the 25. We always end up here at line 25. Okay. And the reason why this becomes important is we're going to calculate this cyclomatic number. Let's see. That's up here above this height. We're going to calculate the cyclomatic number, and there's multiple ways that we can do that. The cyclomatic number is basically in terms of graph theory, it is a relationship between the number of nodes and the total number of edges. Okay. And then there's also another thing we'll calculate called P star. And again, that P star we'll get into in the next thing. But basically, what we can see is there's a direct relationship. So if we look back at this over here, if we understand that there's a direct relationship between the cyclomatic number and how many test cases we should have, or at least a bare minimum number of test cases that we should have. Because if you notice here, what I said is we want to have a test case that follows this edge, we want to have a test case that follows this edge, we want to have a test case that follows this edge, we want to have a test case that follows this edge. All right? So just for this one little segment here, lines 5 through 11, so this part right here, this part of is a triangle, just the thing that determines if the thing that we're passing is a real triangle. I'll take a step back in a moment and explain what this code is doing. It's just a simple method to. So anyway, notice that we would want 1, 2, 3, 4 test cases, and we have 1, 2, 3 regions, which I think if I remember correctly, that would be the cyclomatic number. It would be the number of bounded regions. What that means is like, so this is considered a bounded region here. Right, this is considered a bounded region, and this is considered a bounded region. Okay, so it's be the number of bounded regions plus 1. So 1, 2, 3 bounded regions would be plus 1 would be 4. We would want a bare minimum number of 4 test cases just to adequately test this one portion of the code. Okay. Cyclomatic number, let's see, I think, so it's number of edges minus the number of vertices plus P, where P is the number of strong components. So it's that, and this will always be 1. P will be 1 for us. So in the example here where we talk about this, so the number of edges minus the number of vertices. So 1, 2, 3, 4, 5, 6, 7, 8 edges minus 1, 2, 3, 4, 5 vertices is 3 plus 1 would be 4 again. So the number of bounded regions plus 1 is 4. The number of edges minus the number of vertices plus 1 is also 4. Okay, so 2 different ways that we can arrive at that cyclomatic number. One other thing is we can also have a condensing node, this condensation graph, where we take some components and we condense them. So if we look at kind of this here, we could condense this down to a single node. The reason being that it's one bounded region, and so in a way, it's what's going on with this here. Right, is we're taking this if and we're representing it as a single if statement. And this is for simplicity's sake. This is not to determine, again, the number of test cases, but this is for simplicity of representing this graph in a way that, as far as how we as human beings might read the code, makes more sense. Okay. I do want to go ahead and take a look at that example like I was saying. So we'll just look at example 1 here on the PDFs that I shared with you guys. So, okay, the other way to calculate the cyclomatic number would be the number of conditions plus 1. I think it should be number of edges minus number of vertices plus 1, not plus 2, right?
Is this going to be calculated from the code, or are we going to draw the graph by hand and count?
You would want to draw the graph, and you can do that using a tool like there's online drawing tools like draw.io. There's diagram.net. They changed it from draw.io, diagram.net. I'll show you that one.
Okay.
Here. I'll show you that one.
Oh, it's okay. There are many drawing apps. It's okay.
Yeah, and you can, and I mean, when I went through this course in my graduate work years ago, I used PowerPoint. I used PowerPoint to make my drawings. So
okay. I have a drawing pencil, so I'm just gonna draw it on paper digitally.
Yeah,
yeah. I understand better that way.
Yeah. So what I'm going to do is I'm going to separately put these side by side so that we can see them. Okay. So if we look at problem 1, right? So this is the example here, and this is the solution over here. And again, which way you do it, if you do this to the other side, if you do it as a mirror thing, that's fine. It's not about getting it to look exactly like this, right? So what we do is we say, okay, so we start at Q1, we start at 1, right? And then leads to line 2, which leads to line 3. So far there's no branching, right? There's no alternative paths at this point. So then we end up at line 3. Now line 3 results in a 1 or 2 possibilities. You could either go true or you could go false, right? So if we go true, well, actually, the shorter path ends up being false, but so if we go false, we end up all the way down here. So that ends up down to 17, that leads to 19, and we're done. Okay, so then we go the other way. So 3 leads to 4, which leads to 5. 5 is the while loop. So 5, because it's a while loop, if it's false, we just skip over the while loop, which gets us down to 14, right? There you go, 14. And then 14 is the end of that if section, so it goes to 19 and we're done. Now let's continue on and get this part over here. 5, if it's true, goes to 6, which is an if statement. If it's true, goes to 7. If it's false, goes to 10. Both of them reconverge here at line 12, and 12 is the end of the while loop, so it goes back to 5. So in order to calculate the cyclomatic number here, right, we say, okay, we can either do it through the number of conditions, which would be plus 1, number of conditions plus 1. 1 condition, 2 conditions, because the while loop is considered a condition as well. So 1, 2, 3 conditions plus 1 is 4. Okay. We could also calculate it using the number of edges and vertices, the difference of those two plus 2. So let's see, edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yep. Minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 14 minus 12 plus 2. Notice, yep, it's also 4. And then you could also calculate it using the number of regions. So 1, 2, 3. So that's now 3 plus 1 is 4. And basically what this is all about doing is, because as programmers, we might look at a piece of code like this, and we might have a hard time really thinking through how many test cases should I do? What type of test cases should I run? Right? I don't know. I'm gonna have a hard time thinking through some of those things maybe. But here
So
we can kind of
there's
yep.
this. Okay. Why do we add this 1 to the conditions? While we are counting the conditions, are we not only looking at the loops? For example, there are 1 if, 1 while, and 1 more if. Okay, so we have 3 conditions. Isn't it like this? For example, in the first example, the 3rd line, the 5th line, and the 6th line are conditions.
Mm-hmm. Right. So the cyclomatic number for our purposes, it's more of a math concept, and so as far as its like purposes and definitions, that's a little bit not so much what we're talking about. But for our purposes, it has to do with testing, and so the reason why we add that 1 is because it becomes this path. So let me pull back to this, the very first thing we talked about here. Okay. So here, this sequence, okay? So if I just looked at this one example here, that one, this example here, the cyclomatic number of this would be as defined like this would be the number of conditions plus 1, right? All right. And how many conditions are there in here?
Yeah, only 1.
Well, there's none.
Right.
There's no conditions at all because this is just a sequence, right?
Yeah, but okay.
Yeah, and so if we were to say, well, there's no condition, so the number is 0, therefore we don't have to test this. Like, wait, no, that doesn't sound right, does it? Or if we looked at over here, if we said, hey, there's one bounded region, there's one condition, so that means one. If we set our number that's important, you give it some other name other than cyclomatic number because that's not what that is. Then if we were to say this is 1, then we might be tempted to say, oh, this requires one test case. The problem is that we want a test that goes this way and we want a test that goes this way. Okay, and so that's why we add that 1. Basically, what that cyclomatic number is representing is every time we have a condition, that means we have another branch, which means we need to add some other test to make sure that that branch is seen, to make sure that we have tested the code that falls into that side of things. Okay, so we want to make sure we test this path, we want to make sure we test this path, we want to make sure we test let's see, we want to make sure we test this path, we want to make sure we test this path, we want to make sure we test this path, we want to make sure we test this path. All right, so that would be 4 in that situation. Okay?
Yeah, thanks.
Sure. So there's some more examples in here. And like I said, we'll go over P star next week. So, but there's some other examples that get kind of really interesting with the way they end up working out with the graphs and the way they can be drawn here. And like I said, I'll be giving an assignment based on this here next week. One thing also, the syllabus says that there will be a midterm exam. Because of the way things have happened this semester, what I will do is we will end up not having an online midterm exam. And what we'll do is I'll do something else. I'll have some other type of way to calculate your grade for this course. So, okay.
I couldn't hear. So are we gonna have a midterm?
No, we're not going to have an actual exam on midterm. I may I may just end up doing it based on assignments or I haven't made a final decision on that. But I will not be giving an actual exam on the like Microsoft Forms and stuff. I'll have something else to fill that portion of your grade.
Yeah, not to intervene, but our other lecturers are also thinking the same. Instead of
Okay.
midterms, they are giving projects, but
Yeah.
the projects are usually taking a longer time than a normal homework. They
Yeah.
are
My main thing I want you guys to work on is I want you to work on this term paper. I really want that to be the most important thing. And so that's why I don't want to make you have to study for some exam. I'm not giving a project that's going to be due in a week or two, but I am the term paper and the presentation will be what that'll be the majority of this course. That's what I want you to work on.
okay.
Okay, and that has already been assigned, and that you should already have been looking at. Okay. Yeah, because here it is, your term paper, and there's an assignment in there, and you know what we may do is just make the term paper, you know, something like 60% or 50%, and make the other assignments some other percentage. Yeah, but there won't be an exam, and there won't be a mid-semester project. I'm not doing that.
Okay, so
Okay.
it is best if we start on term paper now.
Yeah, you should already be at least doing some research for that. So go ahead, and if you haven't already,
I'm
definitely be looking into articles
I'm
and stuff.
I'm trying to decide on a topic. So I want to examine the software quality in video game development.
Good.
But the problem is that do we need to be novel? in terms of our paper. Is it okay?
It's more of a, I would say for this, what I'm expecting is more of a literature review. So more of a what is state of the art out there right now. So what is recent research showing right now?
Okay, so my main goal is to do research on the topic, but not to provide any further research questions and examinations. Just to correct myself.
Mm-hmm.
Okay.
Yeah, we won't be doing an exam. Nope. No, we will not be having a midterm examination.
Okay then. Thank you very much.
Okay. If you know out there, if you don't have any other questions related to what we've talked about here, go ahead and take a look at the graph stuff. And like I said, I'll be preparing that assignment based on graphs and based on the structural testing that we'll go over next week. And I'll assign that.
Okay.
Okay.
Okay then. I don't have any more questions. And
All
thank
right.
you
Well, I
for the
guess
lecture.
yeah. I don't think anybody else on the call has any other questions either, right?
Yeah. I don't know.
All right. Well, thank you out there. I'll see you guys next week, and stay home, stay safe, and hopefully we can get past this pandemic soon.
Yeah, you too. Thank you very much for the lecture and everything.
Have a good weekend.
You too. Goodbye.